It's a great pleasure to have Achim here speaking to us from Air Gradient. And I'm sure Achim will tell you a bit about his background. Well, I hope he will, because it's a really interesting story as to how he got involved in air quality. But the long and short of it is that, you know, his personal exposure to the effects of air quality resulted in him setting up a company which now manufactures sensors and thinks about how to help individuals and institutions use those sensors to achieve their own aims. So Achim, without further ado, I'll hand over to you.
Yeah, thank you, Henry. Let me just share my screen, and then I will just start exactly where you started to introduce me. Can you see my screen?
Yes, your screen is displaying perfectly.
Okay, good. So yeah, Henry, you were spot on. It's basically Air Gradient started with this event. So in 2019, I'm living in northern Thailand, and which has like seasonal air pollution through wildfires primarily. Every March, April, we call it the burning season. And 2019 was really bad. So this was really a picture from the terrace of my house. And you can imagine that, yeah, the air quality was just really, really bad. And this was actually not just like a day or a week. It was over like a period of like 2 months. And I always like to show this picture here, which is a NASA satellite, which actually tracks wildfires. And you can see that at that time, the whole like northern Thailand going into Myanmar, a little bit into Laos was just basically full of wildfires. And the air quality was really hazardous. So we were kind of around 100 times above WHO annual guideline. And this was obviously a peak, but for that period, March, April, I think we never were below like maybe 150 micrograms. So it's a period with like people were extremely stressed on how to protect themselves, and our kids go to a nearby school, and it was actually the first time that the school had to close. So the principal basically really informed the parents that basically the school is not able to handle the situation anymore. Even so, they had very powerful air purifiers in each classrooms. They just couldn't cope anymore. And at that time, like I was on a sabbatical from a previous job, and we just saw like how the principal was actually running around with a PM meter in his hand and trying to make sense of the situation, putting data into an Excel spreadsheet. The campus is huge, so from one end to the other, he was probably walking like 10, 15 minutes to basically just understand the situation. And another parent who is an electrical engineer, we were thinking, okay, there has to be a better system, like to really find out what's the situation in the school. So that's basically how Air Gradient started. So we started developing like a first prototype of a sensor platform, just put it into the school, just trying to basically help them to set something up, because it was like a problem that just comes back like every year around the same season. And then at that time I was also parents president of the school. So we were also thinking, okay, how can we actually implement this whole system in a way that it works, that it involves all the stakeholders. So we set up an air quality committee chaired by the head of school with representatives from parents, from teachers, from students, from the operations team. And I was actually driving not only setting up the sensor network and a platform, but also like, how can we improve the air quality policy of the school? How can we create awareness with teachers? And then it went from a small pilot of, I think, 30 sensors to a bigger pilot with 50. And then all the schools in the area here have the same problem. So they got notice of it. Then we provided them with some sensors. We started doing workshops for students as part of this awareness training. We did a lot of community outreach, like with local firefighters, for example. We made a clean air camp in 2020, just before COVID struck. And we also went on a quest to really find what's the best air quality solution, because even so, the school since probably 10 years had really powerful air purifiers in the classrooms. They just couldn't cope with that situation when PM 2.5 goes beyond like 200, 300 micrograms. Then only basically, yeah, we actually founded the company. So you can see a very long period of time, we just tried to fix a problem basically for our school, for the community. And then because it was just clear that there's so much demand, and we said, okay, let's just formalize it. And we founded the company. Then soon after, we had first customers in China. With all this community involvement and the students, we said we want to make this actually an integral part of the company. So we founded this Air Gradient for Education. I have a slide for this in a second. Then we extended the platform into demand-controlled ventilation. And then the last year was actually really characterized by having our 8th generation of sensor developed basically for a global rollout. So we went through all required certifications, also reset certification for air quality. At the same time, we continued actually with the open source educational kit, which is on the right-hand side. So yeah, welcome to visit that website. It's an open source, open hardware project. People can just build their own air quality sensor. I will come to that point later on in the presentation. For the professional sensor, just a few words. So it measures, I think, very typical 5 parameters: PM 2.5, CO2, temperature, humidity, TVOCs. And this is the DIY kit, which actually uses very, very similar components. So you can actually build a very, very accurate like air quality sensor yourself. And this has been done by a number of schools and nurseries. There's a case study on our website, and they can actually, if they don't have a big budget, actually save thousands of dollars and have a very powerful air quality monitoring system, because they can actually link it to our platform as well. Out of that kit, our open source hardware, what's interesting is a lot of ideas. We have a forum on our website of people basically extending it. So we had, and I'm touching on a few things later on. We have actually a small teacher's display in classrooms, and in one school in Bangkok, they kind of 3D designed the enclosure together with students and made, I think, some kind of competition. Then another school took this IKEA toy that was broken, put in a microcontroller with an, basically like this part here, with an LED, RGB LED, and then it's connected to our platform. So if the air quality is good, it's green. And this was put into an early years classroom. And then if it turns red or purple, actually the kids put a mask around the toy to basically, yeah, for awareness and to tell the other kids, okay, now you should wear a mask when you go outside. A few words about the platform before I go into this human behavior aspect. Just for you to understand, like, what's the basic functionality of the platform before we go into that topic. So obviously every platform handles like current data, historical data. I think what's different on our platform, because we started with schools, with a school that has basically 100 classrooms, we had to find ways to immediately visualize what's the situation in a large scale organizations. So we found ways to basically show this aggregated data. I show in a second. I think another key thing is that it's really performant, it's fast, easy to use. So the main dashboard, you can see here, was actually, this screenshot was done during a smoke season. So you can see extremely bad outside air quality with 168 PM 2.5 micrograms. You can see the school policies integrated. So all outdoor activities are canceled at this level. You see the development over the last 12 hours. And then on the right-hand side, you get an immediate overview about the situation in the rooms. So you can see that like maybe around 20% are green. And most of the rooms are in the orange and red zone. So this is US EPA coloring. You can see the worst rooms on the top. So you see the library is at 144, which is the worst, basically indoor polluted room. And then you can see the other rooms here. We also focus on CO2. So you can see that close to half are actually okay. And then we have an average of 861, which is still good. Also, the worst classrooms are only at around 1200, which for a classroom, if you don't have fresh air ventilation, is actually pretty good. We see sometimes classrooms going beyond like 3,500 ppm sometimes. And then you can see through all the, basically all the locations. And then you can also click on the location and you can see like, okay, what was the situation, for example, in the last 24 hours, you can compare it to the outside air quality. The close time is gray, so that's probably not interesting. There's no kids are in the school. And during opening time, you see the colors. Yeah, so this was just a very, very brief introduction into the platform. And my aim for today, or the topic for today is really, how can a platform encourage behavior change? And I want to separate this into two different areas. One is really directly embedded features into the platform that trigger behavior change or hopefully trigger it. And a second part is a little bit more like how you can actually use air quality data when you communicate with the community to increase awareness on air quality, and through the awareness, obviously, encourage a behavior change towards a better air quality. So I want to just go through a number of features, some obvious, some less obvious. Some were also actually discovered accidentally. So I think one of the most important things when it comes to behavior change, especially when we talk about schools or large organizations, is like clear responsibility. So you need to talk to people, to responsible people, to maybe principals or teachers of a certain area in the school to really make a change. And what we try to do, for example, is we can group classrooms into certain areas. And we always like to look, okay, to group in a way that there's one responsible person for that basically area of the school. So what you see here is, for example, this school here separate into early years, junior school, senior school, and common areas. And the idea is behind, because we have a principal for the junior school who's actually also taking care of early years. We have another principal for the senior school, and the common areas are more under, let's say, facility management. So if we see here that, for example, the common areas are much worse than the other classrooms, it's very clear where we have to go to and talk and see what's the problem and how can we fix that. The same thing is also then displayed, for example, on public displays or website integrations. I will cover that later on. And that was more something we found out accidentally. So what we did implement is, like, we have a daily report that goes to all the teachers in the school. And the daily report actually lists the worst classrooms on the top. So you can see here, for example, S17 has the highest PM 2.5 with 61, and then it's the Blue Med area with 56, and then it's going down. So a few weeks after we implemented this, I was actually presenting at the teachers meeting. And then some of the teachers said, hey, Achim, you know what? Like, nobody wants to be number one. I said, what do you mean? I said, well, nobody wants to have the worst classroom in the school. And we always now try not to be number one. And this was a really eye-opener, because it shows you like how we actually created a kind of healthy competition between the teachers just with a report. And so this is like, I think, a very good example of how you can structure data to basically trigger a human response, or maybe even some kind of natural behavior, basically. I think also what's really important, that we often, or basically all the time, we see very, very different levels of awareness, or also air quality acceptance. It goes from people that say, hey, air quality should be basically, or particles should be basically zero, like not accepting like any tiny bit of air quality. And then we see other people that basically say, hey, my lungs are strong, like I can manage, you know? So what we want to do, or often, or actually every time we go into a school, we start a discussion on, okay, what's your targets? Where do you want to be? Like what's the commonly assumed objective for air quality? And what we promote is the WHO targets, which are now 5 micrograms for PM2.5 for the annual guideline. And we actually integrate this into our charts, so that people, when they use the platform, that they can actually see that's actually where we should be. But another really important aspect is relaying information, I think. So we hook up a lot of different small and big displays with the platform, which you see at the bottom here. So, and we have different like styles and different configurations. So on the right-hand side, for example, is a display inside a gym of a school. It's powered by a Raspberry Pi. And you see what's the air quality inside the gym, which has a powerful purification system, and what's actually outside. No? And this is visible to everybody, like to the teachers and also to the students. And often we actually have the case that the students will tell the teachers, look, it's not good outside. Let's keep the game inside the gym, for example. So it just communicates very well the air quality without the need to, you know, look into your emails or opening your computer and seeing a dashboard. I think what's a real powerful behavior change is when you come to the point where you can actually market clean air. So if a school really invests into like having a really good air quality, we see some schools that basically just stop there and say, okay, it's a health and safety thing. So we address this issue. You know, the same like you would have a lifeguard at the swimming pool, for example. But then there are other schools that actually say, look, this is an opportunity to actually market the school, to actually maybe drive enrollment or reduce, like keep retention very high inside the school. And here's an example of a school that did that very well. So on the top left, you see the air quality is part of the main menu. You see an explanation why good air quality is really important. And then you see the real-time values with a widget that we provide. So if you come to a stage where school really uses this in a way as a kind of identity of the school itself, no? Then obviously there's a very strong drive from all levels of the hierarchy to make sure the system works, the system is improved and maintained. Another, I think, very important behavior change is to integrate the air quality or combine the air quality basically with the school's air quality policies. So here in Asia, most schools have a very dedicated air quality policy that basically gives clear instruction on what should happen on various levels of different air quality. And we implemented it in a way in our system that you can see here. So on the left-hand side is a typical air quality policy of a school. based on US EPA levels. We have these 6 levels from good to hazardous, and they basically have exact instructions on like what's the school policy for different grade levels, what should happen there. So what the system does, if a band basically changes and it stays within 30 minutes on that band, because we don't want to have like spikes and going back and forth different levels, the respective policy for that band is automatically sent to basically the concerned parties. Could be PE teachers, could be head of school, whatever you set up. So they get a notification here which tells them exactly, hey, listen, be careful, we entered, for example, the orange zone. This is what you need to keep in mind. So with this system, the people are basically adapting their behavior based on changes in air quality. Now, most of the things that I mentioned, maybe besides the marketing aspect, was more on like short-term reactions to changes in air quality. I think what's also really important is how can you actually improve long-term the air quality? How can you reduce students' exposure to bad air quality? And here we actually provide an air quality report or air quality certification if schools meet WHO standards. In these kind of reports, and I show a complete example in a second, we can point out classrooms that need improvement, for example. We can compare different types of ventilation systems. And this regular audit or assessment with the report really lays the foundation for this kind of continuous step-by-step improvements of a school, for example. So what I want to show is an example report from early last year, which is a real report. I just want to go and highlight a few things. So it first explains what's really the purpose of the report. It's a third-party assessment. What's that it estimates students' exposures, and what are the targets that we look at. So the targets, for example, that we take is the WHO targets. At that time, it was 10 micrograms. Now, late last year, it changed to 5 micrograms for the annual air quality guideline. And then there are also interim targets from the WHO, which we took in because for some schools, it's obviously, especially if they are in polluted areas, it's sometimes not easy to immediately hit the air quality guideline. So we want to take or provide basically interim targets so that they can step by step see their progress towards cleaner air. Then we quickly describe basically the testing procedure, the period, that how many rooms basically are monitored, and then we provide a management summary. So we look at what was the average classroom here, for example, had a PM 2.5 level 2.64 micrograms, outside was 51.7. We look at different facilities. We look at different equipment. So here you can see that the positive pressure system rooms that use positive pressure to clean air outperformed basically rooms with standard purifiers by a big margin. So the PTIS rooms were only at 3.44 micrograms, and the ones with the traditional air purifiers at 23, still less than half of the outside of 51 micrograms. And then we basically go into each of the location, each of the classrooms, but we start with the outside air. So again, it was like 51. And then these are a few classrooms that have this positive pressure system installed. You can see that they actually achieve a purification performance of like higher than 90% in most of them. And obviously meeting all the WHO targets. But then we also have areas that look a little bit more like mixed. So here we can see that it's mostly about air purifiers. And we can see, for example, what's interesting, for example, the cafeteria. So we can see that they actually have the lowest purification performance, or second lowest, with only 38%. And we can see they even have problems reaching internal target 2. And obviously a cafeteria is difficult to maintain for healthy air, because you have a lot of, like, you have the kitchen basically integrated in the cafeteria, which produce a lot of, like, smoke basically, and then also all the ventilation systems from the kitchen can kind of suck in air from outside, and a very tricky space in general to purify. And then another room that doesn't work well is basically the product design room. And this was something that the school really looked into, because first they didn't understand what's the problem there, and then they found out that the 3D printers of the school basically creating a lot of particles. So they had also an indoor pollution source. Then we take these different areas and try to look what's actually a typical student exposure. So assuming that the student spends 20%, for example, of his time in sports facilities, 20% in common areas, 60% in the classrooms, we can actually then provide an estimate on what's the student's exposure throughout a school day. So this is based on the WHO guideline of 10 micrograms, which was a pass at that time, wouldn't pass anymore now because it's 5 micrograms now. And then we give basically recommendations to the school on how they can go and like improve certain areas to, step by step, like improving the air quality. So these were all like data-driven aspects directly from the platform to encourage behavior change, some immediate basically changes based on sudden changes in the air quality throughout the school day, others more longer term improvements. What I want to talk now is about how actually the community or the data can be used when working with the community. And we just had like maybe I start with this. This was longer ago. So when we implemented the air quality at the school here in the pilot, we did a lot of roundtables. And one roundtable was actually about how parents want to have air quality reported from the school. What do they want to see from a monitoring system? So we discussed topics like short-term spikes versus long exposure. Like if somebody celebrates a birthday in a classroom and they lit the candles, like this is not gonna create a long-term problem for the kids in most cases. So these spikes probably not as important as what's the continuous exposure in the classroom over the whole school years. Then also discussed like levels of details, like do they want to see data in all the classrooms or on a more aggregated level? How should that data be made available? Like, do they want to get it by email or they log in on a website? And what's the importance of seeing each individual's classroom? And I don't want to go into all the minutes, but I just copied them in to just show a little bit what the workshop focused on. So it started with basically defining what's the purpose of a school communication for air quality issues. No? What do parents want to see? Like, do they want to see that the school is taking action? Do they want to see the data? Do they want to just make sure their kids are safe and well? Is it maybe about trust and accountability? Is it about how the school allocates resources to create a cleaner air? So a lot of different aspects were discussed in what's the purpose of the reporting. Then we looked into what kind of different channels are actually there how should the data be communicated? How often should it be communicated? Yeah, that's what I just said. And then also, like, what's the content? Like, should it be only particles? Should it be CO2? Should it also cover like things like heat index, temperature, humidity, or TVOCs for chemicals? Do they want to see certain trends, longer term exposures, or maybe just for the school day, and so on? So what was the result of that, for example, of that workshop? Was that you can see that on the right-hand side, so that the parents' discussion actually influenced very much how that report for the parents was designed. So this is available in the parents portal of the school, so they can log in with their password, and then they can see the air quality for the morning period from 7:15 to 12 and from 12 to 3:30. So the idea was here to give them a level of detail that smooths out these sudden spikes that just could create anxieties, but still give two averages for periods. So for example, if a child is very sensitive to air pollution and the parents see, oh, it's actually not good, maybe they want to pick them up at around lunchtime. No? So this was one of the purposes here. We focused on PM 2.5 and CO2 as the two key metrics. And parents also can really see in each individual classroom what's the air quality there, because I mean, every room can be different. So it didn't really make sense to make an average across like a number of rooms. So this is an example how really that kind of workshop with the data defined basically how air quality should be recorded. Sorry, that was my phone. And then we have made a workshop with just actually last week, or this week actually, yesterday, yeah. So with NARID, which is the National Astronomical Research Institute of Thailand. And the objective was basically to get high school students from all across Thailand, 4 regional workshops, to talk about how they can increase air quality awareness with understanding how to use air quality data. And part of that workshop, which was actually sponsored by the US government, was to put like 30 air quality monitors into 30 schools all across Thailand. And you can see a picture here where the students actually work on basically how to use the air quality monitor. We designed a very special dashboard, a very simple dashboard for them with the US AQI based NARID created this kind of different phases for different air qualities, which you can also see on this printout here in Thai language. And then we have the different schools. So at the moment you can see air quality is pretty good since like 1 or 2 weeks. So this is an example how the community can actually work with data and increase the awareness. Another example with the same organization was a month ago, where actually university students came and built air quality sensors. So this workshop was a little bit more oriented towards the technical side, like understanding how does air quality measurement really work, how does a PM sensor work with the laser scattering method, how can the data be analyzed, but also with the aim to really encourage positive change, like that they encourage to measure the air quality in their community and then talk to the responsible persons, like how can we improve this. It had also the technical aspect. So we used the open source, open hardware air gradient for education kit. So people actually could change the code of the sensor, and they actually soldered it. So you can see this here, where they actually built this small air quality sensor. Yeah, so this was basically the example of the community awareness through data. And I want to just give a quick outlook on what's actually the next step. And for us, the next step is really like, how can we actually measure behavior change? So at the moment, we try to trigger it, but we don't really know how successful are we in like kind of changing behavior towards a better air quality. So what we see is a model with basically 3 loops, and one is the air quality measurement, obviously, where we also look into like what characteristics do we have in the building and the occupancies. We detect incidences. We need to set or define what is an incident, like what does high CO2 mean, for example? How long does it have to be high? And these kind of aspects. Then these incidents are communicated with the participants. There can also be surveys. And that hopefully triggers some behavior change. But then we need another loop to really observe and detect if the change really happens. So this is something where we want to get to really kind of measure the success of triggering behavior change towards a better air quality. And one way this could be done, for example, is that if the system detects a certain spike, for example, here for CO2, that the occupant, for example, gets a message and say, hey, your CO2 suddenly spiked. Are you having a lot of guests? Are you having a party? Are you exercising in your home? Give some information, and also then the link on what's actually the health impacts of high CO2. So to get a real direct feedback from occupants, basically. Good. Now, the last slide is basically 3 key takeaways, which I just want to underline before we go into a discussion and questions. So I think that the 3 main important pillars of like triggering or improving or using behavior change for better air quality, I think is once like target all stakeholders of the organizations. Like we often go into schools where like maybe one person is very passionate about improving the air quality, but the whole organization is not really behind it. And this is often where it kind of fails or it gets stuck. So I think it's really, really important that you target all stakeholders in the organization. So head of school, teachers, parents, students, as well as like the operations teams, for example. Then secondly, I think it's really important to not just focus on one communication tool, like, for example, reports or benchmarks or certification or displays or even workshops, but to really, I call it a communication mix, like to really look at a lot of different ways to communicate and trying to basically use as many as possible, and also looking at what works and what doesn't work in that organization. And then I think lastly, if we can incentivize healthy air quality achievements, then we come into some kind of like self-enforcing loop that they see, okay, the more we do to create healthy air, the more we can actually win, the more we can gain. It might be just prestige or it might be profitability. But if we manage to get into this kind of cycle, then it's basically a self-enforcing loop. And that's the ideal situation for, I think, this changing human behavior. Yeah, so that's so far my presentation. Let me know if any questions or discussions.
Thank you, Achim. That's a lovely presentation. There are a couple of questions in the chat, which I will, to save, to avoid any technical issues, I'll just read out. But if people have questions they want to ask, they can either put them in the chat or they can just raise their hand and they can then ask them themselves. So the first question in the chat is from Sarah West, and it came sort of relatively early on in your presentation. Why was the air quality worse in the common rooms, and who is responsible for these sorts of areas? I.e., you know, who in the school can make changes that affects those kind of areas?
I think the challenge with common rooms, there are very, very different types of common rooms. So it can be like a library, it can be a fitness room, or it can just be an auditorium, for example, no? Which has very, very different characteristics. So if a school wants to invest in improving air quality and they have like all classrooms are the same and they find a system that works, all the classrooms are basically safe, no? But the common areas are often very different. So that's why we often see that the focus is first on the classroom, also because the students spend most of the time in there. And then basically as a second step, looking in common areas. I think another challenge in common areas is often that you have a lot of entry and exit points. So there can be a lot of cross ventilation, for example, that just brings in a lot of bad air and makes it more difficult to manage. They also often like doors are opened all the time and closed, and not like a classroom where, you know, at the beginning of the lesson it's closed and then it stays basically like this. So I think that's what I can think of.
Thank you. And then the second question is from Run Ming. And the question is, what are the challenges of measuring air quality in a classroom? And I think the question is in terms of spatial variation, how many points should be measured to be representative of the classroom? And in terms of the placement of the sensors, are there any sort of guidelines, and do they ever create distractions for the children?
So the sensors that we typically put into schools or classrooms are totally silent. They don't have any display, they don't have any LED lights or anything. So we just kind of silently measure the air quality. Regarding placement, normally classrooms are pretty well, I mean, the air, we put in, like, when we analyzed the thing, we put in like 2 or 3 sensors on different corners, and we had very, very similar levels of air quality. And probably it's just because of the movement of people inside the classroom. Sometimes you have ventilation through air conditioners that very quickly distribute the air. But we try to avoid is putting sensors like next to windows or doors, where they just could have an outside influence very quickly. What's also important, I think, from a practical point of view, we try to get the power outlet from the ceiling, because we often had, like, at the beginning, we had sensors going offline because students were charging their phones or computers and then didn't put them back in. So I think that's an important aspect of just making the system work continuously. How many points should be measured? We measure like around typically every 90 seconds, which so far was sufficient to get a really good sense of the situation. Yeah.
I think that how many points might have been spatially within a room rather than the frequency.
Okay.
And there's a question from Emily, who's very interested in your dashboard and wants to sort of understand a bit better to what extent is it automated or fixed in terms of what can be seen, and how much can the schools interact and customize their view?
Yeah, so basically we have like our main dashboard that is pretty fixed, I would say, with the screenshot that I showed earlier. So just covers PM, CO2, and then you can scroll in and see the other variables like TVOCs, humidity, temperature for classrooms. What we have besides this, because that's also a dashboard where people have to log in and basically actively approach it. We also work a lot with these kind of small displays that I showed. No? So schools can also set up just a URL basically showing, for example, a teacher's classroom plus the outside air quality in a very, very simplified fashion. And that's actually something that is very popular. So people just put it on their home screen and they immediately see, okay, my room is like this, outside is like that. I think that's, so far we didn't get too much requests to have it totally customizable. I think it just didn't come up so far.
Thank you. Sarah, you have your hand up.
Thanks. Hi, Achim.
Hi.
So I had a question about, following up from the question about the common room, and I wondered if part of the problem with the common room is not only that you have the doors and windows open, so there's lots of air flow coming in from outside, which, as you showed right at the beginning, the outdoor air quality can be a real problem in Thailand. I wondered if it's also an issue of ownership, because you talked about how that kind of benchmarking within the school meant there was a bit of competition to not get the worst classroom. And I wondered if that plays into that as well, is that, it's kind of, if it's not your classroom, there isn't that incentive to make it better.
Not too much, actually. Like, we often have also very clear ownerships on like common areas. Like sometimes they are part of, the senior school, for example, or part of the junior school. Also like sports halls, for example, like we have athletics directors or head of the sports department. So we try to address it to them. What could be a problem areas like auditoriums or libraries, they're a little bit more tricky. There we often go just like to the operations teams. I'm not sure if that's part of the UK schools that they have that. But that's also like maybe the most challenging areas from a responsibilities point of view, because often the operations team doesn't have this kind of health and safety glasses or goggles on like a teacher. They're thinking more in terms of, does the light work or do I change the bulb? So, but I would say maybe 70% of the common areas we can pretty clearly like allocate to a responsible person.
Thank you.
Great. So I think that's all the questions that the audience have for you today, Achim. Just remains for me to thank you for a really excellent presentation. Really interesting work you're up to. And I look forward to seeing you all here same time next week.
Okay.
Bye-bye.
Thank you. Yeah.